Hey everyone, welcome back to my channel EduVibe. Today we will start with the another topic of trigonometry. As well as we do trigonometry of grade 11th math. Today we are doing the angles in the standard position. So this is the main topic of the trigonometry from where you start from the basic and you do the other topics in this grade 11 math and you do the more standard thing in grade 12 math. So this is the main topic, very important topic, and you get the more and more questions from that topic in your final exams and in your tests or quizzes. So let's start with this. And first topic is that angles in standard position. So basically we're doing this and then we do the reference angles. So both are like interconnected topics. And so let's start where we can find the standard position. How can we find the reference angle? So in trigonometry, angles are often interpreted as the rotations of a ray. So this is kind of the rotation in the Cartesian plane. You all know that we have that Cartesian plane data type, and you can see this over there. This is that y-axis that has the x-axis. So this whole thing is very important when you do the unit circle, when we do the cast rule. So that's the thing there. We have a coordinates. You all know that we have quadrants in this. So it's the first quadrant, second quadrant, third quadrant, and this is the fourth quadrant. And that rotation they talk about in trigonometry, the angles are interpreted as those of the rotation of the ray. So firstly we have an initial arm. Where does this start? So from that point they start doing the rotation. That is the main initial arm, and this is starting position of the angle. Then we have a terminal arm, which is the final position of the angle. So we can rotate something. We rotate by any degree of angle, and that line where they goes and they stops, that's called the terminal arm, which is the final position of the ray. Angle in the standard position, it has the vertex is at the origin of the coordinate grid and this initial arm on the positive x-axis. So it's all base is the base is that our origin, which is 0 comma 0. So start from initial arm is ends on terminal arm wherever the angle is in the first order and second, third or fourth. Angles in standard position are always known as the Cartesian plane x or y grid. So x or y grid is the Cartesian plane where the angles of the standard position can be found. X-axis and the y-axis divides the plane into four quadrants. As I already told you that we have a four quadrants. And these ones are very important when we do the reference angles. So we have to know that how in which quadrant how we can find the reference angle, because every quadrant has different style to find the reference angle. The first one always stays the same. The first, whatever the standard angle is, the reference angle stays the same for the first one. Second, third, fourth is quite different but not very different. So next we have the example for the standard position term we did on it. So firstly we have 36 degree. So when we get any type of the angle, any type of theta you can say. So first we have to know that what is that, from which quadrant they lie. So basically I will tell you that it's roughly over there that if this is the first, this is the second, this is the third, and this is the fourth. So from here we start with the 0 degrees and this up to 90 degree. So angle between 0 degree to 90 degree is all under the quadrant 1. Now this is 90 degree and this is 180 degree. So from 90 degree to 180 degree, the angles between them are all lie on the second quadrant. Then this is 180 degree and this is 270 degree. All angles from 180 degree to 270 degree lies between the third quadrant. And at the end, we have over here 360 degree, and from 270 degree to 360 degree, we have all the angles in the quadrant 4. So that's how the breakdown of the angles or the theta values are being divided. So these are very important when you do your circle in the next video. So 36 degree and 36 degrees in the first quadrant. So all of this lies in this first quadrant, and we have to make that thing. So if I raise this now, so here I have an initial arm. Here's our initial arm, and they go 36 degree. So just till this over there. So this is just 36 degree, and we've made that type of arrow. This is a rotation arrow, and this stays the 36 degree because it's on the first quadrant. So this is your terminal arm, this is your initial arm, and that you can see your 36 degree. And this is our quadrant 1. So let's see the second one. We have a second one is 210 degrees, 210 degrees. So it lies on this quadrant, in the third quadrant, 210. So that rotation goes further. So if I raise this, so if the initial arm stays over there and we get the rotation up to there. Stats is our rotation up to now. Now from here to here, this all is the 210 degrees. So which we have here. So this whole thing is 210 degrees. But we want the thing because this angle basically is on the third quadrant, and we have to write over there that this is in the third quadrant, but angle should not be like 210 at the third quadrant, because we have to find only that angle which is between that from here to here. So that angle, this angle we have to find basically. So from here we can start thinking about the reference angles, and the standard deviation is also like more likely as I go to both are the relatable topics for both of them. So to find this angle, so you always know something like if I again made the angles of the lines, that this is 0 degree, this is 90 degree, this is 180 degree, and this is 270 degree, and this is 360 degree. So from when we have any angle and we have to find the standard deviation of angle of in this quadrant, which we find for this one, so we always do 180 degree because this is 180 degree. So we always do 180 degree minus the theta for the third quadrant. For third quadrant, we always do this 180 degree minus theta. Or because the 180 is greater, 270 is greater than 180, so you always do something like this also, theta minus 180 degree. So we learn more about this, but theta is greater, so we get the minus value if we get 180 minus theta, because theta has a value greater than 180. So theta is the value of 210 degree over there, and minus we do 180 degree. From here we get 30 degree. So that 30 degree is our kind of reference angle we have to find. So that's how we can use the reference angles in the standard position too. From the standard position we get the reference angle. From reference angles we get the standard position angles. As we see in the next one, which is 315 degrees. So 315 degree is here to here. We can't do 270 degree because 270 degrees is such a like a random number from between the any angle. For this quadrant third, for the quadrant 4, or for any quadrant, we didn't use 270 degree. We always use for second one or the third one, we always use 180 degree minus theta and theta minus 180 degree. For this it stays the same for first one. For fourth one we do 360 minus theta. So now for this is 360 degree minus theta, which is 360 degree minus 315 degrees. You will get about 45 degrees. So how can we make this? So I quickly erase this, some of them. So for making this, again it starts from here and it go all the way to this, like this. But their angle is between there. Not over there because it's like large angle as compared to this. So 45 degrees is this, and this lies in the quadrant 4th. We do more and more question. We do one fill in a blank table to know more about the standard deviation and reference angles. But now we'll start with the reference angles because they are more relatable topics. So let's start with reference angles. So each angle in standard deviation has a corresponding reference angle. So as I told you that we do this is standard angles. These all are the standard position angles. That angles all have their some reference angle with their standard angle. So that's all they tell you about there. All the standard position angles have their corresponding reference angles. The reference angle, I mean definition about that, the acute angle. So you can see you made that type of acute angle for the reference angles. This is the reference angle in this. Formed between the angle's terminal arm and the closest x-axis. So you can see this is the closest axis, that's why I made over there. This is the y-axis. That's why I made this 45 degree between that x-axis and the terminal line, which is closest to that. When the angle's vertex is in the origin, so this always be in the that origin. Note that the reference angle is always positive and measures between 0 degree to 90 degree. So it's always be positive and it's always between 0 to 90 degree, not greater than 90 degree. You can see you get for this, you get this is remain 36, you get 30 degree for this, quadrant 3, quadrant 4, you get 45 degree, all are between 0 to 90 degree. And the reference angle theta are shown for angle theta in centimeter, where the theta is less than equal to theta and less than 360 degree. So basically that is the range between for the standard deviation angles to get the reference angles, and the reference angle has the notation of this theta r, which is to all the reference angles, and for standard deviation you just write the theta for that. So you can show this, that table you have there. So you have a quadrant 1 which is equal to theta is equal to reference angle, you can see, and where the angle stays you can see over there. For quadrant second you have 180 degree minus theta, and you can see that reference angle goes over there, not over there because it should be closest to the x-axis. Then you have quadrant 3, this is theta minus 180 because now we have a long big angle than the 180 degree, so we get the negative answer. So that's why we do theta minus 180 degree. We can't use 270 degree. I repeatedly say that. So here's our reference angle. For quadrant 4 we have 360 degree minus theta, and we have that reference angle over there. So that's how the angles we can make. Sometimes that theta, from theta to reference angles is very like easy one, but from going to from reference angle to theta is sometimes trickier. So we will see that example now, that how we can go from the theta to reference angle to theta, and we also see some examples when you do a table. So let's see that over there. So we have to make the reference angle of 20 degrees. So we have 4 quadrants. We have to make in all 4 quadrants this angle. We have 4 graphs over there. So for the first one, the reference angle is over there, and this is 20 degree, and from first at the first corner we stays at 20 degree, stays with the theta which have. So this means our theta over there is 20 degree and reference angle is 20 degree. So we made just 20 degree over there. It's just a small angle. So this is your 20 degree. Yeah, so you can make. For next one. Next one, we have a reference angle of 20 degree. But now we have made in second quadrant. For second quadrant, what we do? Now we go from, we have to know that what is that thing, that this is 20 degree, and in second quadrant what angle is that, what's the theta is in the second quadrant. So basically when we go from a theta to reference angle, you go 180 degree minus theta. From here too you can do 180 degree minus theta. To go from reference angle to theta, you do 180 degree minus reference angle. That's the same thing you will do. So 180 degree minus 20 degree, you will get 160 degree, which is your theta, and this is in the second quadrant. So reference angle, this is your 160 degree, this is the ray diagram, and this is your reference angle of 20 degree. So you can see now that if you go from reference angle to theta, you will do 180 degree minus theta, and for reverse too, you do the 180 degree minus the reference angle. Stays the same, but this is right. So the reference angle is 20 degrees, stays the same. For third one, the third one is more trickier because you will start from here again, but now we want for third quadrant. So the reference is 20 degree. So for reference angle to theta for this one, you will do 180 degree plus the reference angle. Now you do plus. So 180 degree plus 20 degrees, you will get the theta of 200 degrees. Now we do the plus for this. You do addition for this. So this is your 200 degrees rotation, and this is your angle of 20 degrees, which is the reference angle. That's the thing you do. For the last one, you will do again the same thing from reference angle to the theta. You will do 360 degree minus reference angle. So 360 degree minus reference angle with 360 degree minus 20, you will get 340, which is your theta. So this is your reference angle. This is your 340. It goes like this, and this is your 20. So that's the thing you have to do. You have to memorize this, that all thing, because in the first one everything stays the same. Reference angle always remains the same. But for this you have to remember for all three. But for second and fourth are stay the same. This one is always be students forgetting this, that you have to plus for this, not the negative. So that's the thing you have to do. So next one, as I told you, we have a table for this to fill the things in this table. So we have a rotation angle in Q1, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we have a reference angle and we have a fill in the blanks. So we have a reference of 28 degree. So what's in the rotation angle of, if we have a rotation angle, we want rotation in quadrant 1. So what's this? So it stays the same, which is 28 degree. For quadrant 2, we have to do 180 degree minus 28 degrees. So which is 152 degrees. For rotational quadrant 3, you will do 180 degree plus 28 degree. You will get 208 degree. All the things you have to do plus and minus, because just know that how the reference angle can be found with the reference angles. Quadrant 4, you will do 360 degree minus 28 degree. You will get 332 degrees. For next one, same, quadrant 1 is 39 degree. This is 180 degree minus 39 degree. You will get 141. Then 180 degree plus 39 degree. You will get 219 degrees. Then 360 degree minus 39 degree. You will get 312 degree. And from here you can see more of the thing, that this is a degree. This is not the degree actually. This is a variable. So this stays the same. This has 180 degree minus this. This is 180 degree plus this, and this is 360 degree plus this. You can see that. This is minus. For the next one, you have only quadrant 2, which is 114 degree. From quadrant 2, you can find the reference angle. How? Stays the same. So 180 degree minus 114 degree, which will give you 66 degrees. If this is 66, this stays the same. For quadrant 3, 180 degree plus 66 degrees. You will get 246 degrees. 360 degree minus 66 degree, you will get 394 degree. You can see if you have the random angle, quadrant 2, quadrant 4 you have. So you can easily find the reference angle, then you find the other angles. Now you have quadrant 3, so 201 degree. You go to the reference angle, so which is 201 degrees minus 180 degree, which will give you 21 degrees. This stays at 21 degrees. 180 degree minus 21 degree, you will get 159 degrees. 360 degree minus 21 degree, you will get 339 degrees. So I think you have like a head shaking thing in your mind. You could do a 180 degree positive, then negative. All the things you'll done with this table. You can done this table with your own if you want. So skip that answers and get that table by yourself. Done by table yourself. If you want the extra practice, so you can comment me in the comment box. I will give you the more example of this like this. If you get the last example we have, so we have the most common question like this too, which is determine the three angles between the 0 degree to 360 degree which have the same reference angle rotation of 303 degrees. So to find that some rotation angles from 0 to 360 degree which have we have to find the reference angle time from 0 to 360 which have a rotation of 303 degrees. So basically first one, which is 303, is more likely closest to a 360 degree. So you can firstly what do, you do 360 degree minus this. When you do the minus of this, you will get 57 degree. So which is between this. So you get 57 degree first. Then you have 57 degree as the angle. as the coordinate first or as the reference angle 2. So for coordinate 1, you have, for coordinate 2, what you will do? So for coordinate 1, you will do 180 degree minus 57 degrees. You will get 120 degree. This is for coordinate 1, this is for coordinate 2, for coordinate 3. 180 degree plus 57 degrees. You will get again 237 degrees. They given to us the last angle, but they want the three angles. So these are those three angles between 0 to 360 degree. If you have the rotation reference angle as the this. So that's the whole thing you have to do in the reference angle and standard position. You have to just know that how can we go from reference to standard or standard to reference. Just that thing, and we have used that things now in the upcoming lessons. So you have to be strong in that skill, or you can say that method. So it's very important. So that's all for this lesson. Learning is simple with EduVibe. Learn smarter but not harder. Please like, share and subscribe to my channel. If you have any questions, let me in the comment section. And in the next video, now we'll start with the methods to find the trigonometric ratios. There are different methods to find. So if you know this thing, now we'll do that lesson 2 with your like full potential if you know this. So see you in the next lesson. Till then, stay connected with EduVibe.